Hello guys, today we're gonna go with another term, important term, that is velocity. So, what basically is velocity? Well, velocity is a rate of change of displacement with respect to time. So, velocity is just a rate of change. Alright, so there are two basic types of velocities. The first one is average velocity, and the second one is instantaneous velocity. Now, what is the average velocity? Well, as I said, velocity is rate of change of displacement. So, in a journey, let's say my total displacement was final position minus initial position. As we discussed in the previous video, displacement is final position minus initial. And it took me, let's say, 3 seconds to go from S1 to S2. So, the rate at which I was moving is my total displacement divided by total time it took me. Delta t, that is t2 minus t1. Final time is minus initial time is the change in time, that is delta. Delta always means change. Alright, delta denotes or represents change and any quantity. So this is the change in displacement, so I can write this one as delta S over delta t. So rate of change of displacement over time, that is rate of change of displacement with respect to time, and that's velocity. But here, this average velocity. And what do I actually mean by average? Why not instantaneous? What's so different about instantaneous velocity? Well, what is different is this. If I'm at point A, alright, I'm moving to point B. Now, let's say the distance between B and A is 5 meters. And it took me 2 seconds to reach this point. So my average velocity is, as per this definition, gonna be delta S, that is, I'll just first write the definition, and then delta S is 5 meters, B minus A, that is 5 meters. So I covered displacement of 5 meters, so my displacement over how much time it took me for the displacement. It took me 2 seconds. So 2 seconds. And don't forget the units. Now what are the units of velocity? Well, velocity is displacement over time. So what is the unit of displacement? The unit of displacement is meters, right? So meters divided by, of course, the unit of time in seconds. So unit of velocity is gonna be meters per second. So velocity average over here is 5/2 meters per second. Okay, now what is instantaneous? When I calculated average, okay, I was just only concerned with my final position and initial position and my overall journey, alright? But if I break this journey into small parts, alright, by knowing average velocity, I won't be actually sure about the velocities at this point, because my velocity may not be constant overall this journey. Alright, because all we are doing over here is calculating the displacement and time. Alright, and that's the way we are calculating displacement. But the rate at which I'm traveling, that is the rate at which my displacement is changing over time, may not be same throughout all points in this journey. That is, let's say I may be traveling the first 2 meters with x velocity and then other 3 meters with y velocity. Alright. But still, if the time for me to reach to point B, if it's still 2 seconds, then it doesn't matter if the velocity changed or not, the average velocity is still gonna be 5/2, because it is only concerned with the time took and the displacement. But if I have to find the velocity at instance, I have to do some other procedure. Right. So veloc average velocity and instantaneous velocity will be same if the velocity is constant over the journey. But if it's changing at every instant, alright, that is if the velocity at instant, let's say a prime is not equal to a double prime, the instantaneous velocity at double prime, the average velocity may still be the same, 5 by 2, but the instantaneous velocity is changing with each point in this journey. Because instantaneous velocity is at an instant, and if the velocity is not constant over the whole journey, then that means that at every instance the velocity is changing. So instantaneous velocity is changing, but the average velocity may still be the same, right? So how do we denote instantaneous velocity? Well, V instantaneous is velocity, of course, is always delta s over delta t. So it's delta s over delta t. But what is changing over here? The only change being that at an instant, the time duration is very small. When we say it's just an instant, we mean a very short duration of time. So this delta t is very, very small. Alright. So we can say that this is tending to zero. And by tending to zero, I mean it's so very small that it is very on a timeline. Oh, sorry, I'm on number line. It's very near to zero. It's not equal to zero, of course, but it's very, very near zero. So I can take limit as t tends to zero. Alright. So of course this is not zero. Alright. If this is zero, then whole quantity is gonna be infinity. 1 by 0 is infinity. So well, if it's zero, that means I have not traveled anything. Alright. Okay. So let's say if it's zero, then I've traveled infinite amount of displacement in nearly nothing of time, so my velocity is gonna be infinite. Right? As the denominator is decreasing, the mole fraction will increase, so velocity will keep on increasing to infinity as t equals to 0. Okay, so here is t is just tending to 0, not equal to 0. So it's for the people who know calculus, this definition may seem familiar. It's differential of displacement with respect to time, derivative of displacement, ts by dt with respect to time, of course. For people who don't know calculus yet, don't worry, we won't be needing calculus much in the beginning. Of course, we need it in higher level courses, but and if you don't have any idea about calculus, I'll make a separate video on describing some basic concepts in calculus as well that we may be using in physics. Okay, so here for now, velocity instantaneous is ds over dt. That is delta s over delta t when delta t tends to 0. So that's our instantaneous velocity, while that's our average velocity. So that's the basic difference between instantaneous velocity and average. Please don't get confused between these two concepts. These may be same or may be different depending upon the situations. Alright. Okay, that's it for today. I'll see you in the next video. Thank you very much.